Gold is one of the most stable metals, which is why it's found pure in nature and why it's been used for centuries for jewelry and coins. Today's lesson is on the reactivity of different metals. Some metals are very stable and they can be found in the pure form in the environment and don't often form chemical compounds, for example, gold. Other metals tend to corrode, tarnishing or rusting, for example, and these metals form chemical compounds more easily. So, for example, corrosion is the oxidation of a metal. So, in a lab simulation, for example, we can have four different metals immersed into four different ionic solutions, and the results are recorded. If nothing occurs, no reaction will be noted. If a change occurs, then a reaction will be noted. And some of these changes will be things like a color change, bubbles, precipitate being formed, so on and so forth. The results are as follows. So when magnesium was placed into a magnesium solution, there was no reaction. When it was placed into a copper solution, there was a reaction. A reaction with zinc and a reaction with silver. Copper had no reaction to any of the solutions. And zinc had no reaction to any of the solutions. And silver had no reaction. Zinc had a reaction to copper and silver. Copper had a reaction to zinc. And silver had a reaction to no solution. So I'm just going to highlight those reactions for you here. So magnesium reacted to copper, zinc, and silver. Copper reacted to silver. Zinc reacted to copper and silver had no reaction to anything. So we want to rank the ions in order from most reactive to least reactive. So when we can see that silver in the far column was the most reactive ion because it reacted with 3 of the 4 metals, followed by copper, zinc, and magnesium. When we want to rank the metals from most reactive to least reactive, magnesium was the most reactive metal, followed by zinc, then copper, then silver. So we can see that the more stable a metal atom is, the more reactive it is as an ion. So silver atom was the least reactive, while a silver ion was the most reactive. So you have a list called an activity series in your data booklet, and this gives us the reduction half reactions. So this organizes metal atoms from the most reactive to the most stable to the least stable. So we have increasing strength of oxidizing agent. Okay. So we have our most stable metal atom here, and our least stable metal atom here. So simultaneously, metal ions are from their most reactive to their least reactive on the opposite side. So this is on page 80 in your textbook or page 4 of your data booklet. So when you read from left to right, we get a reduction half reaction. So if we have cadmium here, plus 2 electrons gives us a cadmium solid. We're reading a reduction half reaction when we read this way. However, when we read right to left, we get an oxidation half reaction. So if we go cadmium solid, gives us 2 electrons, and cadmium 2+, we're losing electrons, so we get that oxidation half reaction. So we're able to go reduction one direction, oxidation half reaction in the other direction. Now this activity series allows us to compare the relative reactivity of metal ions using the left side, whichever is listed closer to the top, compared to the relative reactivity of metal atoms using the right side, or whichever is listed closer to the bottom. So we have more reactive ions at the top and more reactive atoms at the bottom. So that activity series allows us to compare the relative reactivity of metal ions using the left side. Whichever is closest to the top is more reactive, and the reactivity of metal atoms on the right side, whichever is listed closer to the bottoms. So we're able to rank them in order of most to least reactive using that activity series. So To determine if a reaction will occur spontaneously, this is one that's going to be active, spontaneous without any addition of any additional energy. And to determine if a reaction is spontaneous, we want to locate the two half reactions on the table. If the reduction reaction left to right is located above the oxidation reaction, it will occur spontaneously. A non-spontaneous reaction will have the reduction reaction located below the oxidation reaction. So if reduction is above oxidation, it will be a spontaneous reaction. So, as an analogy, a travel agent does not travel herself, but allows someone else to travel. In a similar way, the oxidizing agent is the one that causes the other substance to be oxidized, and the reducing agent causes the other substance to be reduced. So in a net reaction, the reducing agent is the one that causes another substance to be reduced and is oxidized. So a reducing agent is oxidized. A reducing agent is oxidized. And an oxidizing agent is itself going to be reduced. Now, when we look at gold, which was the top atom on our chart, it is the least chemically reactive metal, and it's most likely to be found in pure form, which is why you can mine for gold. It's least likely to form ionic compounds, which is one of the reasons why it's an excellent conductor that can be stretched into very fine wires. It's also favored for jewelry and coins because it is a pure metal that does not want to react, and it's favored for electronics and computer manufacturing, again, because it's not going to react to other elements and compounds in its environment.
If you enjoyed this video, check out our website online.plrd.ab.ca and visit us on Facebook, Prairieland Online Academy. You can find out all that's going on with Prairieland Online Academy.